So welcome back. Last time we had talked about just an overview of this lesson and some like the major points within dplyr. I want to drill down and talk about specifically what these functions are doing. Again, just kind of as an overview before we get into filtering or subsetting rows with filter. So the filter command is going to return rows that match a certain set of conditions. So you should think back to the previous lessons where we talked about relational subsetting of a vector, either an atomic vector or a non-atomic vector. Filter will work exactly this way under the hood. It's going to be giving you rows of a tibble or of a data frame that match where you have some logical value that resolves to be true. Okay. So you can think about filtering and say, okay, well, I have a column of the sex assigned at birth of all of my patients, and I want to find all of the rows where this column is equal to female or equal to male. And that's what filter is going to allow you to do. You say, okay, give me the data set and then pipe it into filter, filter to where this condition is true, where the sex assigned at birth is male or sex assigned at birth is female. Or you can say where age is greater than or equal to 18 and less than or equal to 35. These examples that we had talked about in some previous lessons. Arranging, as I mentioned before, this is just, it's sort, either numeric or alphabetical or a combination of the both, alphanumeric sorts. Select allows you to kind of rearrange and organize where the columns are in your spreadsheet. I know that sounds dumb, but it's way more powerful than you might think. Especially if you're dealing with huge databases so you can have, and these aren't even huge, these are just moderate size, but we'll get spreadsheets from the CDC with hundreds, if not thousands of columns. And there's no way for you to wrap your head around what's going on in that data set without using select to get at the features, the measurements that you really think are important for your analysis. Mutate, this is all about feature engineering. Create new columns, most often as functions of your existing columns. So you say, okay, well, I have height and weight. I'm going to use mutate to create a BMI based on a function. Or I have a variable that I want to talk about that variable, but in a standardized scale. So I need to subtract all of the values from the mean and then divide all of those by the standard deviation to get me values into like a z-score where I can compare that against a z-table or something like that. Group by and summarize always go together. Or I'll put it this way. If you ever see group by, there will be a summarize. There are some instances where you can use summarize without group by, and in those cases, it's probably that the by argument is actually inside of summarize. I'll give a brief tip on how to do that and where to get more information on that later. But usually just think about like group by and summarize as like a package deal. So this is Lucille Ball and Ricky Ricardo, like they come together. And then finally, we said that we're going to talk about the join functions, and these are the workhorse of data science, and that allows you to connect multiple data sets from multiple sources as long as you have a unique ID, a unique either patient ID, or you rarely ever work with social security numbers because we don't have that kind of power. Or zip codes or county names or something like that. But join is what allows us to take information out of multiple tables, connect it together to perform subsequent analysis. One hugely important tip, the dplyr functions. So whenever in Microsoft Excel, if you add on a new column and you say, okay, this is my new column is, and then you type the equal sign, and then you type a function or something to create a new column based on the data that you have, that new column is there in your spreadsheet. In dplyr, this is not the case, okay? When you start a data pipeline, and you go through the steps in this data pipeline, it does not add the information to your original data set that you started with. The original data set is like holy and sacred and set apart. It is not to be touched, okay? When you perform these data wrangling and data cleaning, data manipulation operations, you should always save the new data set into a new object. dplyr will not create new objects for you. You must do this yourself, and please do not overwrite the original data. Make sure that your original data is sacred and not to be touched. The data pipeline should take in the original data, and then all of your manipulations, all of your cleaning steps, all of your wrangling steps should result in a new data set, not to overwrite the original data set. Please do not do that. Okay, so, and then obviously dplyr comes from the tidyverse. That's like 90% of this class comes from the tidyverse. So we're loading the tidyverse. And here is a dplyr cheat sheet for you. I had to update this link recently because it wasn't working. But here it is. This is the old school one. This is the one that I learned with many years ago. I think there's an updated one, a newer version. So if you find one that looks a little bit different online, that's totally fine. This is like in my head, these are kind of like the main points of dplyr and what we're going to be going through over the next couple of videos in this lesson. So let's talk about filtering. But first off, I told you at the end of last lesson you needed to install this package NYC Flights 13. Here's a look at what the data set is. This again is a tibble. Hey, look, a tibble. There's about 337,000 rows, and there are 19 columns. Obviously, this data set is not large, but it is large enough that if you had to go through this information by hand, it would take you a long time. So that's why dplyr is going to be coming into play here. Very helpful data set, very helpful package of functions. One second. Sorry about that. I thought I had everything on silent. So yeah, this data set, as I mentioned before, like if you were going to try to go through this by hand, it would be very tedious, very time consuming. So we're going to use dplyr to get at some of the components of this data set. And the first thing we're going to talk about is how do we get subsets of the data? And that's with the filter command. So right here, if I want to find all of the flights that happened on January 1st, then this is how I would do it. I've got a column here for the month. I've got another column here for the day. You recognize this. This is a logical comparison. This is logical subsetting all over again. This is just saying, give me the month column and find all of the times, all of the places where the month column is equal to 1. This is going to return a logical vector of trues and falses equal to, let's see how many of them, 336,776 trues and falses. And this is going to be true. This part is going to be true for any time you are in the month of January. This one is going to be another about 337,000 trues and falses. But in this case, it's going to be true for January 1st, February 1st, March 1st, April 1st, et cetera, et cetera, et cetera. And so you end up with 337,000 trues and falses, another 337,000 trues and falses, and then there's the and that happens. That's what this like it's just saying give me the rows where both of these things are true. Both is the Boolean operator for and. If I want both things to be true at the same time, this is an and. So we're basically going to say, okay, I've got these two columns of trues and falses with 337 some odd values. Where are they both true? In that case, they are both true for 842 flights. So there were 842 flights that went out of New York City in 2013 on January 1st. So that's what this is doing. And notice here, all of these functions, filter, arrange, select, mutate, group by, summarize, all of the join functions, the data set is the first argument. Now, if you remember back, this is important because the pipe operator takes whatever comes in the line above it and puts it into the first argument of the next function. So all of these functions are designed to work with the pipe operator. And here we see this code right here is equivalent to this code. What we're saying, though, is take the flights object and filter it so that we get January 1st, all of the flights on January 1st. Okay. And here are some examples. Again, pipe operator turns f of xy. We would write it as x piped into f of y. And it allows us to read code from left to right and top to bottom rather than inside out with a giant nest of parentheses. This one wouldn't be so bad. Just a single filter wouldn't be so bad. We don't need to use a pipe operator here. But if we get into the habit of using the pipe operator now, when we have to connect all of these operations together, it just goes simple, smooth as butter. All right, so here's an example. We want to find all the flights on Christmas Eve. So obviously we're going to December 24th. There are 761 flights, and here's what they look like. Another one, give me all of the flights in the summer month. So again, check this out. We're still doing logical comparisons. This is Boolean subsetting, but it's happening inside of the filter command. So we recognize this infix operator. Say, give me all of the values. So this is a true or false. This is going to return about 337,000 true or false values to mark whether or not this column called month is either a 6, a 7, or an 8. Okay? And then right here, we recognize this one. This is not equal to. Now, how did I know that EWR was the code for Newark Liberty? Remember, data science is the intersection of code, math and stats, and domain knowledge. I had to get a little domain knowledge here to find out that Newark Liberty Airport, the airport code was EWR. So this is give me every flight so that this column called origin, where is it? Okay, it's down here because there's 19 columns. It doesn't even fit on the screen anymore. So this column called origin should not be equal to. So do not give me the flights from Newark Liberty. And there's about 216,000 flights that were either out of JFK or LaGuardia, the other two airports in New York. And then if I wanted to find all of the JetBlue or Southwest flights, I guess I could throw Spirit in here as well as the airlines that I don't particularly care for. They're a lot cheaper and sometimes treat you like cattle. That is my personal opinion. That is not the opinion of my employers or, disclaimer, yada, yada, yada. I just personally don't care to fly on Southwest or JetBlue or Spirit. I haven't been treated really well, but again, this is not the opinion of my employer, just mine. So if I wanted to take a look at these flights, because I am biased against them, I say, okay, give me all of the flights that were Southwest. Now, again, how did I figure out what this is? That Southwest was WN or JetBlue was B6. Again, domain knowledge. I had to read about the data sets. I had to find information about the data sets that's not just included in the data set. Most of the time, you're not going to be so lucky as to have all of the information about the data in the data itself. There's often, almost all the time, there's going to be meta information about the data, and there should be. So anyway, I'm saying give me all of the flights that are on this B6 or WN airline, i.e. JetBlue or Southwest. And there's about 67,000 of those. And then this is, since I've flown out of LaGuardia quite a few times, this is a bit of a joke for me. Give me all of the flights that actually left LaGuardia on time. And there's about 68,000 of them. Good job, LaGuardia. Okay, and I think that's all for filter. But again, just understand that what we're doing here is we are creating logical comparison operators. So we've got the origin column, and we're going to create a column of trues and falses for whether or not origin is equal to this character string capital L, capital G, capital A. And then I've got another logical comparison operator that says give me all of the values where the departure delay. So let's see, this column right here is less than or equal to 0. And notice here I used an and symbol, whereas above I had used a comma. So right here, I used a comma. The comma will give me the and operation. The and symbol will give me the and operation. However, what is interesting to note is the or operation. I can't use a comma as a shortcut, obviously, because the comma is the shortcut for the and operation. I need to specify the or operation directly. Okay, so that'll be all for this part of the lesson, and we'll pick back up with the next lesson, and that is sorting rows with arrange. And I think that one's going to be pretty short, so I'll also start getting into the select function as well. So see you next time. Bye.